calculus in 9th and 10th standard. Please enlighten us, sir.
So, of course, a student is still perhaps learning basic trigonometry and things in that area when they're in 9th and 10th grade. And I personally propose they be pushed back maybe a year or two. Trigonometry, for example, to 8th grade, or algebra to 8th grade, as is done in the US. Because I think that trigonometry and algebra are concepts that are more easily connectable to the real world. For example, variables are really just numbers that may change over time, or numbers that we don't know. Or you can express, for example, the price of something over time when prices inflate as a function. Or you can express the gas per liter of a car as it gets older over time as a function. Or you can, and basically algebra and trigonometry are present everywhere in the real world. And calculus is present as well, but it's not very easily viewable to these 7th and 8th graders. So I think it would be very helpful to 9th and 10th graders to understand the calculus that comes in the next few standards if they already understood trigonometry and such, and they were able to learn calculus in that grade. So of course there definitely can be some flexibility in what grade you take it. It could be calculus in 10th grade or calculus in 11th grade. It doesn't, there's no rigid system, but I recommend that it should be pushed back by a little bit, because it would be very helpful for students who are learning physics in the next years to actually understand what's going on in their physics classes. But they don't understand it that much. There are so many logarithms, and there's so much differential and integral calculus. I can say in my country, physics and calculus, taking physics with calculus is not required, at least not in high school. But if you do it, then it's only for 12th graders. And of course, by 12th grade, you will have already learned Calculus 1 and Calculus 2. But here, from what I am hearing right now, that is not always the case. Sometimes the calculus curriculum is falling behind the physics curriculum, which doesn't make any sense. How are you supposed to apply something to the real world if you don't know what it is in the first place? So I fully advocate that at least the curriculum should lay down on its usage of calculus, or the course of calculus should be pushed back to account for the fact that physics is getting ahead of it.
Yes. Now I want to know from Dr. Ranjit Chaudhary sir. Please give your opinion.
I think Professor Bari is right, and I agree with him that one can learn calculus at 9 and 10, that is alright, but one cannot skip the other courses, because without knowing trigonometry, one cannot learn calculus also. Without knowing coordinate geometry, one cannot learn calculus, integral calculus or differential calculus. Am I right, Mr. Bari?
Of course.
Yeah.
It takes, it definitely coordinate geometry in specific.
Yeah.
That is almost basically required to get any understanding of what a derivative is or what an integral represents.
Yeah. But just if the student can learn it very fast, suppose he or she can learn it at 7 and 8 level, the basic algebra and basic trigonometry, then it is alright that he or she can learn calculus in 9 and 10. That is alright. But one cannot skip the discipline, skip the courses.
No, I will stay with what Professor Bari is saying. He's not telling us to skip. What I understand from what he wants us to do is, we need to, let's say we are presently, if you look at this, trigonometry is being taught in class 11. Right? What he is asking us to do is that don't look at class 11th only. Let that trigonometry come down. Similarly, any topic which is there, we see in India, if you see the jump from class 10 to 11 is huge. Huge difference.
Yes.
In the mathematics, in the physics, in the chemistry. And then we are expecting a child to work from there. Where what Professor Bari is saying, it will continue in the same manner. But you bring down from the lower classes. The concept need to be started much lower classes so that it becomes easier for him to continue with the same subject or the same concept in 11th and 12th. It is easier for him to understand. So that exactly, I have the same propagate I have been telling my staff also. No child for that matter, no child. We cannot say that he cannot do it. And today in the morning also, Professor Bari was saying the same thing to us. That it is you have to, challenge yourself. There are opportunities, you have to seek those opportunities, you have to challenge yourself. Now, how do you challenge yourself? That just the concepts that we keep working, okay, in class 10th only he will learn this, in class 11th only he will learn this. That need to be challenged, and we have enough, even in our school also, we have brilliant students who can do much better or they can do the same things in a much lower class. But since we don't change, we are continuing with the same system of teaching. That is where we feel that okay, class 11th I will learn this, at 11th class when he goes to class 12, he will learn this, up to 10th we will only do this much.
Yes.
So what Professor Barry is telling us, actually we need to implement that we need to bring down the few concepts related to that same topic in the lower classes so that they become useful and they know why it is being taught.
That is why, sir, Professor Bari also mentioned about the calculus 1 and calculus 2.
Yeah.
It's like as the lower level, basic level calculus. And are you want to mean in that way, sir?
Oh, calculus 1 is just the American name for differential calculus.
Yes,
Calculus 2 is
exactly.
just the American name for integral calculus.
Okay. Right.
No, actually, in this case, what will happen? The concept learning will become better because what I was exactly saying before, that is, if a student simultaneously learns physics and maths in class 11, it becomes quite difficult because maths is not there, calculus is not there. It has just started, and physics teacher has already taken the place.
Yeah.
So it becomes difficult. So it should be introduced. I fully agree. And
We also want to know from you what changes we need to bring into our system, the present system that you see in India. What kind of system you propose that since you go to different countries, you have been interacting with different kind of people. What is your proposal? How we need to improve upon the things which you feel is still we are lacking in, especially related to maths.
That's a very good question. So, of course, in this system in India is much more rigorous than in the U.S. But in the U.S., one thing that is very unique to the U.S. that's not present in India is that you can actually sort of choose what courses you take in math and when you can take them. For example, Calculus 1 is actually available to 9th graders, and Calculus 2 is actually available to 10th graders. Although most kids do not take it because it's too hard for them. And for example, algebra is even available for algebra is even available for 7th graders and 8th graders, even though most choose to take it in 9th and 10th grade. And if you don't want to, you can stop learning math after pre-calculus. But if you want to, you can keep learning math until calculus 3 in linear algebra, which is usually done in your first year of math major college. So it's a very flexible education system. You can essentially choose what year you want to do things, if you want to do them at all. And so it can definitely help people who are trying to specialize in math, or who are having trouble understanding these concepts, or who have no trouble understanding these concepts, so they can go in much faster than any other person.